Now we can start talking about how to find antiderivatives, or how to find that original function that we are searching for. Usually, in the exercises we've done so far, we try to find that um, original function using intuition, but intuition won't always give us the right answer. So this is where the basic integration rules comes in handy. So what the basic integration rules says is that it gives you a bunch of rules that you need to follow in order to find to integrate a certain function. For instance, if we were to have, let's say, a function c, the derivative of a constant is just 0, right? Then the integral of that 0 will give us a constant. Or why? Because we are trying to find the original function, and then the original function is this c here. If we look here, we have the derivative of k of x will be k, whereas the integral of k is just k of x, because we just return that x that we removed from differentiation here in integration plus a certain constant. It's the same here. The derivative of k times a function is just k times the derivative of that function, which is k times f prime. Then the integral will also be the same. We can take the constant outside of the integral, and then we just integrate over f. The sum of two functions in a derivative let's say the derivative of f of x plus g of x will be f prime of x plus or minus g prime of x, and that will be the same in the case of integrals, because we'll have the integral of f of x plus g of x will just be the integral of f of x plus the integral of g of x. The derivative of a power function, let's say x to the power of n, is just n to the power x n minus 1. We just, let's say, we reduce the power n by 1. In other words, that if we were to go through integration, which is the inverse of differentiation, instead of minus 1, we need to add plus 1. So the derivative of x to the power of n will just be x to the power of n plus 1 over n plus 1 plus a constant. Why? Because let's say we want to prove that this is really the function that we are searching for. We just differentiate this. This will give us, if we were to differentiate x to the power of n plus 1, it will be n plus 1 times x to the power of n, and then n plus 1 will go with this n plus 1 here, and then we'll end up with just x to the power of n. Um, Now let's go to the sine, cosine, and all trigonometric functions that you need to know. So sine x, the derivative of sine x, as we know, is cosine x. So in other words, the integral of cosine x is just sine x. We go from here to here. A good way to remember that is that let's say you remember how to differentiate such functions, and then the result of that function will usually be the one inside the integral. So you just need to remember what you did. Let's say that you had integral of, let's say, sine x, and then this sine x, you can think of it as the result of an integral of a differentiation that you did before. So what shall I differentiate to find sine x? Well, cosine will give me minus sine x, so I just need to do minus cosine x. That's what is said here, because the derivative of cosine x would be equal to minus sine x. Then this also means that if I want to integral of sine x, I need to do minus cosine x. And then we keep going throughout all um, the formulas here, the rules that you need to know. Just tangent of x is just secant square, and then vice versa. If I had secant square inside the integral, it will just give me tangent